I'm back, and so are you. It's time for some science. Okay, so I am here to take a look at those graphs that Mr. Williams put together in the previous video. We are going to figure out three big things from those graphs. They're the big three things that if you can read them off of this, you can do all sorts of other wonderful things with them. You can find all sorts of other variables. Those three things that I want you to be able to find from a graph are the position, the direction, and the speed of the object that the graph describes. Okay, so let's start with position. When I say position, I mean specifically where that object is at a given time, which means that we need to find the time and then come up to the line to figure out how far it's gone on that line. So if we look here at our table, we have all of our times and the positions right here. So if I ask you, for instance, what was the position at 3 seconds, well, I'd just come down to 3 right there, and I can see that it's 24 on my table. How does that translate to the graph, though? Well, to find 3 seconds on the graph, I'm just going to look at my x-axis because that's where I've plotted time. This is 5 seconds, this is 10. So I can go, let's see, 1, 2, 3. I'm 3 seconds over. And then I just come up to where that meets the line that we've graphed, which is at about 24. You can see that if these are all about 6 increments of 6 centimeters. Yeah, so 6, 12, 18, 24. Yeah, all right. So that's on this first graph, that's how we find the position. You just find the number of seconds and then come up to see where that line meets it. Let's try on a different graph, maybe. Let's find the last position of this object for graph 2. So this graph went 0.9 seconds. So if we go all the way over to 0.9, which is right there, and come up, we can see that it hits at the 40 centimeter mark. So the position is 40 centimeters. You can do this for any one of these graphs. It's the same every time. Find the time, come up to find the position. Now let's think about direction. When it comes to direction on a graph, we don't really have a good signifier of if it's going up or down or left or right. The graph can only tell us if it's increasing or decreasing. It's kind of up to us to decide which direction the position is going to increase in and which direction it's going to decrease in. So in order to do that, we sort of arbitrarily pick a direction and say that's positive. In this case, I've drawn this ball on this surface, and I've decided that if we go right, that's positive. Sometimes it'll say it in the question. Actually, a lot of times it'll say it in the question. To the right's positive. So we are going to look at what direction this ball moves in as it goes along the path described by this graph. So we start with our position 0 here. This is 0 centimeters. And then as we move along in time to 0.1 seconds, it moves 4 centimeters. So I'm just going to draw an arrow just to show that. This is me mapping out what this table and what this graph tells me about this situation. Every graph kind of tells a story in that way. So if I look over at my graph here, if I want to look at what happens at 0.2 seconds, I can come up and it looks like the position is around 8 centimeters, which is also shown on our table here. So it moves again to the right because I've decided that's positive. So it moves to the right another 8 centimeters. And if I keep going along, you can see how the numbers keep going up. 13, 17, 22. If I look over here, there's 13, 17, 22, 27, 31 is right there. This steadily increases, and so I know that it's moving in a positive direction, which I've decided is to the right. So in this situation on this graph, we can see that the ball actually starts at 100 centimeters at position 0. So I'll draw my little ball right there at 100. There we go. All right, so as we move along in the first 0.1 seconds, it moves down to 91. It's at that position now. So even though we've moved forward in time, we're actually moving what we would call backwards. We're decreasing our position back towards 0. So what that looks like is we can draw an arrow down to about there. It didn't move far, but it moved. We can see that it's moved that far in that first 0.1 second, down from 100 to 91. And then in the next second, it moves down to 82, which is about right there. And then next, it moves down to 73, and so on. You can see how steadily the numbers decrease. And so instead of increasing to the right, it's heading towards the left, back towards 0. You can end up in situations where you might have, and this is crazy to think about, but negative positions. Simply because we moved past the point that we arbitrarily decided was 0, and we're now heading off in the other direction, way over here, you know? This is negative 10, negative 20, negative 30. So if we kept going, eventually, if the ball rolls past 0, we'll probably end up way off in this direction somewhere, way over to the left, past 0 into a negative position. Finally, let's talk about speed. Finding the speed based on a graph is as easy as 4 steps. You just have to find 2 points, find the difference in their position, find the difference in their time, and then divide those 2 numbers. So for instance, if I look at this graph right here, let's pick 2 points on here. It doesn't have to be any 2 points that we measured. It can be any 2 points. But for convenience sake, let's pick 2 that we've already measured. So I've got, let's see, this first point right here at 0.1 second has a position of 10. So I'll write 10 right there. And then we'll go to the next point over. Why not? And that one is at about 23, as I can see from the table. So I'm going to find the difference between 23 and 10 by just subtracting one from the other. And that should give me 13. There we go. Next, I'm going to look at the difference in their time. They're right next to each other. So that's going to be 0.2 minus 0.1. I can tell that by looking at the graph itself. Sorry. I can tell that by looking at the graph because that's 0.1 second and that's 0.2 second, and that's where they fall on the line. And the difference between those, if I subtract them, is 0.1. That's a crazy looking 0.1, but that's what it is. So if I now have these 2 numbers, my last step is just divide one by the other. So it's 13 divided by 0.1, which ends up being 130. 130. And the unit that we use for this would be centimeters per second, because those were my units for position and time, and I divided them. So centimeters over seconds. There we go. Now, am I going to ask you to make any of these calculations yourself? No. I'm not really concerned with if you can find the actual speed from a graph. What I'm more worried about is if you can compare 2 graphs and figure out which one is faster. So let's compare these 2 graphs. I have one that is more of a diagonal and this one which is steeper. It comes up at a higher angle. And if we look at this, we can see that between one point and the next, let's say this point and this point, this is 0.1 second going by and it has a position of 4. Whereas during the same amount of time for this graph, 0.1 second goes by and it moves 10. So that's more than double the speed, more than double the distance covered in the same amount of time. And what you'll find is that the steeper that graph is, the faster that object is, always. Which means that if I had a comparison between 2 more, shoot, I don't have any that are the same scale. But hey, I can always draw one for you myself. So let's say I had a graph that looked like this, a graph that looked like this, and a graph that looked like this. And I asked you, which one is fastest? Well, it would be this one because it's the steepest one. Which one is slowest? Well, it's this one because, well, that one's pretty much flat. It's not moving at all. So the steeper it is, the faster it goes. It's a pretty straightforward concept, hopefully. So that about wraps it up for analyzing the graphs that Mr. Williams put together for us. Remember, the three things that I want you to be able to do are find the position from a graph, find the direction from a graph, and compare the speed shown by two graphs. I don't need you to calculate it, although it is helpful to know how and to see where speed comes from, but you do need to be able to look at a graph and compare which one is faster. I hope that you're having a great start to your semester. Have a wonderful day, guys. I will see you around.